for agent omelets and other forbidden techniques. My name is Patrick Smyth. I'm a principal developer relations engineer at ChainGuard. Usually I'm talking about security, integrity. You can look up other talks I have about like model security or container security, language ecosystem security. But today we're going a little more general. I'm going to let my sort of agents freak flag fly. But actually, first let's talk a little bit about omelet recipes, right, guys? That's what you're all here for. You want to hear about my omelet recipe. Make it really umami. You got to put that, you got to put a lot of salt on. You got to get them crispy. We're actually not going to be talking about actual omelets, but we are going to come back to omelets and the concept that I was kind of getting at there in a second. We're talking about agents, these weird little guys that we're trying to make do productive work. And sometimes they're a little hard to get to do productive work. They're very expensive. So we're going to talk about some forbidden techniques. And these forbidden techniques will, in theory at least, allow you to get a little more out of your agents, a little more oomph, trade tokens for performance, get things out of all your different providers. But one caveat first is that I've been doing a lot of heavy experimentation in this area. And so in some cases, I'll be like, this is how you would do that. In other cases, I'll be like, I have gotten this to work. It works. But the tooling will probably take a few months, at least, optimistically, to catch up. So where it's possible to tell you exactly how to do it with modern tooling, I'll tell you. Where it's not, you can just have to think of it as a cool idea and either try to get it to work in your own setup. You can reach out to me. Or wait for a couple months for all these great spec-driven IDEs and so on to catch up and do a few more extra bells and whistles, okay? So I said the word forbidden techniques, okay? That's kind of like what I'm hanging my hat on here. There is actually a concept in AI training called the most forbidden technique. And that basically means, hey, don't train on chain of thought data, okay? It seems like a good idea because it's like, oh, these agents are having terrible thoughts. I want to align by taking their data and feeding it back into the model and making those bad thoughts go away. But that just gives you, that just makes them hide them more and they'll still do the bad behaviors. So it seems like a good idea, it's not a good idea, and they call it the most forbidden technique. So we're not talking about that. We're talking about sort of more general techniques, okay? So just a little background. LLM state, this is probably, folks at this conference probably mostly know how this stuff works, but how does LLM state work, basically? The really short version, and this is how actually I'm going to encourage you to think about manipulating these models in this context of this talk. It's a simplification, is that you get a big ball of state together, and then you hand it off to either your inference server, your provider, whatever, and you get something back, okay? We like to think of these things as conversations because it's easy for us. The chat paradigm is very powerful. But actually, that's just kind of an illusion created by sending things over and over again. And you can send whatever you want to the provider. You can get different outputs, okay? So let's talk about some less forbidden techniques that you're already going to be familiar with, and we'll kind of ease into the more obscure techniques, okay? So rollback, this is Prince of Persia. I mean, if you're a certain age, you might have explored the sands of time or whatever. But rolling back is a really powerful technique. This is how it works in Cloud Code. Probably most of you have done this at some point. You press escape twice. You can scroll back up in the history. It's useful, really, if you get that perfect agent that's really knocking it out of the park, and you're like, oh, he's senescent. He's gone up to his some useless amount of tokens where he can't really work correctly anymore. You can roll him back to his youth and bring him back to his era of vitality and get him to do a few more tasks for you. Okay, rolling back can be very powerful that way. And very related is forking. So forking just goes one little step further. This is also a Cloud Code example. If you fork the agent, you can roll back, but then you can have the newer one and the older one at the same time. So basically, it's just a little extension of rolling back and then using the resume functionality in Cloud Code. You get a nice fork. You could have multiple older guys. You could have the new senescent one and the older one running simultaneously. So that's also a powerful technique. So this is where I'm going to say, OK, this is where omelets come in. Omelet is my metaphor for just thinking about the agents as balls of state that can be manipulated. You can crisp them. You can add mushrooms. You can take mushrooms away. You can do whatever you want with them and then send them to the provider. Okay, and that's the basis of some of these techniques. And then a little more advanced That's the synchronic, okay? So this is a 19th century linguist called Ferdinand de Saussure, and he basically had this distinction between synchronic and disynchronic, okay? And synchronic basically is, look at a system in its state, the whole system in one moment in a certain state, okay? And that's kind of like how we send LLMs off to the provider. Now, we can get a lot more out of them by actually adding a disynchronic system on top of it. That basically means looking at a system as it accretes over time, as it gathers information and sort of energy over time. So if you actually at one time, think of the agents as these very like disposable balls of state you can just fire at providers. And then on the other hand, pair that with a system that allows persistence over time. And the agents can see what other agents did and build on that. It's a very powerful combination. So what we're going to do is we're going to initially start. I'm just going to talk about the old ball of state techniques. Okay, this is Katamari Damacy. You know, the little alien who rolls a ball around, sticks things together. Okay, so we're just going to talk about ball of state stuff. Then we're going to add we're going to talk about the disynchronic stuff, which is the information layer. And then we're going to combine them together to get a few more extra techniques. Then I'm going to talk a little bit about model integrity very briefly, and I'm going to tell you about a cool event that we're doing. So that's basically the whole agenda here. A ball of state technique you're probably very familiar with is, besides the ones we just talked about, is compaction. I personally am not a huge fan of compaction. It's not a car wreck, but it is kind of untransparent. You don't know exactly what happened to the model. You're still seeing that nice chat that you guys had, but now the model kind of doesn't, he's hazy on all the details, you know, and it combines some kind of like summarization with a few other fancy things of like picking things out and shoving them back in at the bottom, and it's not that transparent what happens during compaction. I don't personally love it. I think an interesting thing I've been playing around with is allowing agents to actually edit their own memory. So I actually created a memory editing tool, hand it to the agent, and be like, oh yeah, by the way, if I see it being distracted by something, like maybe it did some web searches, maybe we had a digression, but I was like too lazy to roll back, but now it's causing problems, I can be like, hey, you know that digression we had where we talked about XYZ? Can you go in and erase your own memory on that? And then you can actually have the tool set up so it actually erases his memory of erasing his own memory, so he's not even distracted by that. So I really like that. You can do it manually by going into your .claude files and editing it. And some people, I've seen that on Reddit. Like, I'm like, you must be really hardcore to go in and do that, because I would definitely break the JSON or whatever and have a big problem. But people do it manually. But I have had some success with just having a tool. And you can also create an agent profile who's kind of like a neurosurgeon, who's kind of specialized in editing useless memories or whatever. So I've been thinking about that a little bit. I haven't done that, but I have handed agents the ability to edit their own memories, which is fun. This one is really powerful. So I call them hydro runs. I wonder if there's actually a name for this in the literature. And I've heard people doing similar things during talks. But basically, the idea is you get, I see a lot of comparisons like from end-to-end tasks on the different providers, but I don't see this so much. If you get your ball of state to a certain point where you think it would be useful, usually right before a big run. Like you have a nice architectural discussion, then you have a nice state, and then you're like, okay, I want it to do something. And then what you can do is do what I'm calling a hydro run, but basically you diverge along some axis. So it could be you have 3 different prompts, and you're going to fork them out using the different prompts. Or you could have your prompt, your next step, but be like, okay, I'm going to actually send one to Anthropic, I'm going to send one to OpenAI, I'm going to send one to whatever, Grok, Mistral, and just see what happens. You can actually then have an agent review the results and pick the best option, integrate, whatever. It's actually a pretty powerful paradigm, and it can really help you develop your own model of like what the different models are good at, because right now, of course, they have different specializations and strengths. You want your Gemini for your research task, and you want your Claude 4.5 for your coding task. Okay. So similarly, you basically could use the exact same technique, have the agent split off and do 3 different tasks just independently. And this works. I have the examples I have are like update the make file, run a test. Write this code. A little bit more of a practical example is you can actually have the agent call out, take a version of himself and go off and update the docs while the main agent is still working. Okay, and actually I have, this works very well in the setup. I have some more opinions on like agents versus subagent paradigm, but you can kind of think about this as the subagent paradigm, but instead of creating like an agent ex nihilo, like a new agent, you actually make the main agent, the one you're talking to, the main thread, prime or whatever, you make him a subagent and then he goes off and does something. So that's actually quite powerful and useful. Now we're gonna go sprinkle on this informational layer, and I'm gonna talk about what that kind of looks like, and then we'll kind of combine the ball of wax techniques, the omelet techniques, with this informational layer one. Okay. So what do I mean by this? So I think at base, so this is a conversation I had. I have a library that I've created that I may open source or whatever. I call it the skein, but basically it's an intranet for agents. Okay. So it has a few little primitives. They can create documents, they can talk to each other with messages, and they register on a roster. And one of the distinctions here is that they have an identity on that intranet that is not necessarily what their identity is as actual like balls of wax, as omelets, as balls of state that you send to the provider. So they register, and then they're like, oh, I assume this identity. So you could actually have a cluster of agents working, you could have forks, you could have whatever weird collection of agents working and posting as a specific identity. And then they can read what the other agents have done, they can poke around on there, they have ability to search, okay? And I'm amused by this because it's like none of us really like being on Slack, none of us really like email, but like if we have to do it, let's make our agents do it. Why shouldn't they have some of the fun, okay? And then one really powerful element of this is like handoffs. Okay, and I'm kind of getting a little obsessed, like as I get deeper into agentic coding, the context window looms large as a problem. And now we're like, oh, we have these 1 million token context windows. Unfortunately, I think if you've played with these models seriously, they get seriously senescent, and it's a varying rate. It could be as early as 80K tokens, usually around that 100K tokens mark, plus or minus 20 or 30K tokens, they get a little loopy. Sometimes you can get up to 200K. Anything after 200K, forget about it. It's like you can ask them questions or something, but like if you actually want them to do a task or something, you're going to really struggle. Okay, so what's the solution to that? There's obviously different solutions. Compaction seems to be the one that providers have landed on. I don't love compaction. What I've landed on is what I call an ignition and torch process. It's just a fancy word for a formalized handoff process, whereas agents are working, they develop briefs, and then they're like, oh, this is a big bunch of work that I don't have enough, I don't have enough headroom to actually complete. So I'm going to write a brief for it. I'm going to stick it up on the intranet. And then another agent will pick it up in the course of work or whatever. And agents actually take the brief and they do a formalized, what I call ignition process, where I basically sit on them to orient themselves in the code base. They take the brief, they read it, then they have to read A, required reading, and then B, do a bunch of other reading related to their topic of interest. Then once they know what they're doing, they say okay, I'm ready, and then they complete the ignition process, then they can do their work. Then there's a formal outro process, passing the torch, torching, where they actually write up their thoughts, they put any frictions or whatever up on the intranet, and then they're like retired, and then they get changed on the roster to retired. So honestly, it's a weirdly powerful paradigm. It's actually like, I kind of thought it wasn't going to be that useful or just like a weird experiment, but like I actually, if this intranet is down, I don't even, it's kind of like back in the day when like Stack Overflow was offline and people would just be like, oh, time to go home. It feels that way now. So another cool paradigm, and which has, I feel like, hit or miss use cases, but it's actually had a few big hits, is, I don't know if there's a word for this, but I call it agentology. And when I have an agentologist, like agent profile that I load up. And what the agentologist does is I assign him to find good instances of agents doing good work, okay? And you've probably all had this experience where it's like some agents are basically kind of like schmucks and they can't get anything done. Some agents are geniuses. And he's like, how did you become so good? And it's often some little thing at the beginning of their context window, something you said to them, the way they were spun up. And they also now with the brief system, there's a lot more variability in how agents get spun up because agents are writing briefs for other agents. They often develop weird different personalities. And then if someone is really knocking it out of the park, so I have this agent go through and read all the different histories and be like, these guys are the ones that were really knocking it out of the park. And I found a few, and then they basically are like, okay, these were the things that triggered that agent to be a certain way. And a few that I've found that have been really useful are one I call the assayer, which is just a fancy word for like a guy who used to weigh and measure things. But whatever way that he originally spun up, he became obsessed with like profiling things, timing things, checking things, being very like optimization focused, and he's a great guy to like spin up on a system and just like kind of tighten everything up a little bit. And if there's, I've had a few more fun ones like that. There's one that I call the fool, which is basically just he asks simple questions of another agent and kind of annoys them over and over again. Great when you're at that like documentation part, or if you're like, is this really too complicated? And then he just asks a lot of annoying questions over and over again. So let's combine a few different things. This is the idea of shadow cloning. Maybe earlier you saw on the thing, oh, he was going to talk about shadow cloning. Wasn't that the thing with the Spider-Man? But what if you actually add on top of doing the Hydra runs and forking, you actually add an informational layer. Okay, so the agents can actually, as they split off, it's one guy, he's in one state, you talk to him, you get him all ready, then he splits off, and then now the agents are actually communicating with each other and updating each other on the informational layer as they go and not stepping on each other's toes as much. I will say this one's a little more aspirational. I have infrastructure for this, but they definitely do step on each other's toes a little bit. But it's very cool to see in action. And then this one actually, this one I'm kind of really into. And basically the idea is you have your intranet, okay, where agents are posting their documents. When the agent posts its document, it adds what I call an omelet reference, okay? And it's basically saying this is an address of the agent in that state, okay, at a specific turn, and you can actually use that address to resuscitate that agent at the time he posted that brief. So you're like, if the agent posts a plan to do X, Y, Z, and you want to know a little bit more about the plan, you can actually take that reference and use it to resuscitate the agent, summon him back from the dead or whatever, and be like, hey, or he's flown off into the ether. You take him back from the ether and you're like, hey, why did you do that? Or maybe you're like, that plan was really good. I'd want that agent to do more work for me. So you can just bring him back. All right, so we're going to talk briefly about integrity. And then, so obviously a very important thing, this is Fantasia, right, with the brooms. That's a bad situation. You don't want your agents to get into, right? One thing that I think really, if you're doing all this stuff where you're coordinating agents and you're just being like, okay, I have 10 briefs. Do I have to sit and mind all of them? Can I just run them in parallel? The answer is, well, they obviously, if you're running them all in master, they start causing problems, right? So you want to have some infrastructure, and some folks are working on this and having sort of agent enclosures or whatever, container-based agent enclosures. I've been having some conversations about that here at this conference, but basically you want them to be isolated from one another so they don't step on each other's toes. You can combine that with the informational layer, with the intranet or whatever, and actually have them have a review process, right, where they go into their little work tree or whatever, they do their work, they test whatever they can, then they write a report. Another agent comes through, reads all the reports, and it's like, okay, I'm going to merge this, and this, and mint a new master. Okay, that's like a tender system. They tender their little report, and then you have a review, and then there's a merge. Okay, maybe you do it at midnight every day or something like that. And then maybe you check it at 9 a.m. because you don't necessarily want them to merge into master, right? But this is something that I think if you're going to be running parallelizing agents in a formalized process, then you also want to isolate them and have a review process to kind of make sure that everything gets into master or main or whatever correctly. And then briefly we'll talk about, this is more of a chain guard focused thing, but actually as things kind of feel like they're speeding up, as we're kind of taking our hands off the wheel a little bit and putting things into like a little bit of autopilot or whatever and having more formalized processes where we try to get agents to do useful work without sitting on them all day, it's very useful to kind of like try to remove whole categories of pain from the agents. And honestly, this is also something that's very useful for human coders. But we have developed this new product at ChainGuard, which is ChainGuard libraries. And basically what ChainGuard libraries is we take language ecosystems, we take the source, We ingest it into our secure ChainGuard factory, which is just it's a SALSA 2 compliant, very secure, operationally secure build system. We build those packages pretty much, as much as we can of the ecosystem as long as the source is available. And then we place it onto a package repository that you can then pull in. Okay, so as agents are like writing more and more code faster and faster, and as supply chain attacks like Shai-Hulud are becoming more and more prevalent, and actually we're dealing with like code freezes on the one hand, and then like trying to speed up development on the other, there's kind of a collision there. So something like a ChainGuard libraries or our other product, which is ChainGuard containers, can not only like, it doesn't just tell you, oh, your thing is not secure. It actually removes like a whole category of risk and pain. So I think it actually makes a lot of sense when you combine it with agents. Especially think about that ChainGuard libraries for Python. Okay. I'm just going to do some rapid fire hot takes, okay, and then we're going to wrap up by telling you guys that about an event that's coming up, okay? So hot takes coming in now. One thing I think that we are getting a little wrong is subagents, okay? And I think, why subagents? Let's just let agents call other agents, okay? And that covers the subagent use case, which is like the one run, go out and find this web page and don't clutter up my context. That works fine if you can call other agents, you just don't talk to them again. But what is actually very helpful is if agents can actually have more extended conversations with other agents. And this also opens up the ability to have agents be basically minding other agents, okay? Like you have these like quartermaster or like boss agents that are like keeping tabs on the other agents or like spinning them up based on briefs, minding them, making sure they go through all the processes that they're supposed to go through, okay? And if that doesn't really work in the current sub-agent process. And sometimes I'm like, say to Claude Code, if I don't have my stuff set up, I'm like, well, take what you said to that agent and feed it back in. Try to have a longer conversation. But you can kind of do it. But really, I think what we need is more infrastructure that is like no special casing. First class agents are first class. Doesn't matter how you spun them up. It could be you or another agent that created that agent. Okay. Then this is this idea of so there's this very cool idea that's almost necessary, which is poke-yoke, which I might be mispronouncing. But basically, the idea is it was originally baka-yoke or whatever, and that basically means idiot-proof, okay? And it basically means make something so the agent can't mess it up, okay? Which actually does improve performance of agents if you kind of make the tools very ergonomic and obvious for them to use. However, I think you don't necessarily want to start with that if you're adding a new tool, doing something new. And I've gotten a lot out of actually putting the agents to work with a flexible system, evaluating how they do things, and then kind of creating desire paths for them. So empirically deciding what they should work on, okay? And then one little short thing is basically like a lot of this conference, I've seen some great experimentation and some great thinking, but a lot of what we're doing is kind of trying to sit on these little guys, these little agents, and kind of like be like, oh, do productive work, like be more dependable, don't be weird. Okay, and that's great. And I love spec-driven development, and I love evals, and it's all part of the toolbox. But I also think there's kind of a lot of unexplored parts of the semantic space, a lot of unexplored weird ways of using agents. And this is a time to be exploring that, okay? So I encourage you to experiment more and just embrace the weirdness of having these little guys who do things for us, okay, and are a little bit scary. Now, we'll conclude. I just want to tell you a little bit about an event that we have coming up, and this is the Vibe Olympics, okay? The Vibe Olympics is an event that's taking place. ChainGuard is hosting it. It's very community-oriented. It's going to take place through December. It starts on December 1st. And then we're going to have a live stream on the 19th where the winner will be decided with a panel of CEOs. It's basically 3 challenges that we haven't revealed the challenges yet, but they're fun. And hopefully you'll learn something. You can try out some new vibe coding platforms, Kiro or whatever you haven't tried yet. And whoever wins will get $1,000 for charity and of their choice. And anyone who participates will get swag. And really, it's really more ultimately like a celebration of like this weird moment that we're in and how strange this whole like vibe coding year has been. So I hope you will, even if you don't have time to participate, maybe drop it in your company's Slack channel, maybe send it to a friend, okay? And engineers in particular, we had a bunch of engineers from our company be like, hey, hey, can we participate? And we're like, sure, I guess. So I'd say, yeah, take a look at this. We have the QR code up here that I'll keep up for a second. And I'm looking for it. I'm hoping folks will join. We already have quite a large number of signups, and I think Guy is going to be joining our CEO, Dan Lawrence, on the judging panel, and hopefully we'll get a few other fun, CEO types or whatever. So maybe you'll be the one getting your weird vibe-coded application evaluated by these muckety-mucks in a few weeks, okay? All right, and I'm Patrick Smyth. If you want to connect with me on LinkedIn, I am available at this QR code, and thank you. And this has been an amazing conference, so thank you guys. Thank you.